Hi, welcome to the Shiko Math Practice Lab homework helper and learning through practicing. And we are still in the units talk about the limits, continuity, and differentiabilities here. So in this unit, we have 8 different practice. So 8 topics will be covered in this unit. And we did a lot, we did all the way to the number 7. So now we're going to take a look at our last practice set is number 8, the derivative as a functions here. Okay, so that's what we're going to talk about. This is our practice number 8, derivative as a function. Okay, let's go ahead and go to our worksheets here. So for this practice, basically, we just want to take a look if we treat the derivative as a function, what the type of basically we're looking for the shape and where the value, some specific values and the relation to its original functions here. Okay, so like the first 2 problems here, those are the pretty kind of the basically it's an estimation problem. It's not really any definite solution. You basically eyeball that and think about what it is. So for examples here, I said negative 3, right? So the negative 2, okay, let's take a look at this one. The negative 2, so this is 0, so negative 2 is here. So then you say, oh, okay, so remember, the derivative is the slope of the tangent lines here, right? So this probably very close to 0. And also like here, this is kind of like, so this is like x equal to what? This is 2, right? So f prime 2, probably this one will be very close to 0. It's basically just like you kind of see the graph and then kind of get the ideas, what is the slope, get a rough estimate. So like the same thing here. So you probably can see, oh, this one's here, the f prime. So this one probably will be very close to 0. And that's the same things here, like this one, you say this is 1, 2, 3, 4, 5, 6. So probably this one will be very close to 0s, right? So like if you see here, this is 1, 2, 3, 4. So 4 here, right? So if the f prime 4 is kind of like, so the slope, this is probably is less than 0. So basically just eyeball the data and see what do we have here, right? So remember, right? So if you see that, the things we remember, we did it before is like, if your f of x is here, if f of x is increasing, you at a certain interval, if increasing, then the derivative in that intervals always will be greater than 0. It's because, it's because like like you go, it's increasing, right? So your slope, the tangent line go like this, right? So the slope is a climbing tangent line. So the slope will always be positive, right? And then also you will see here, for certain interval, if x is decreasing, then what happens here? Then the derivative kind of going to be what? Going to be less than 0s here. Then your derivative, like here, like we see here, the derivative, if the derivative is equal to 0, that means it's like f of x changes, right? Changes from the increasing to decreasing, or from decreasing to increasing, right? So let's basically give you an idea. And now let's take a look at number 3. I think those type of problem really is pretty good problems here. And then you will have a pretty good idea what is the the relation between these two functions, f of x and f prime x. So the blue lines here, this is my f of x, and this is the pink one, this is my f prime x. I want to do a match. So like if my f of x is like here, then what could be my f prime x is here? Okay, so the first one I see, it's easy to match is the number part B is here, okay? Part B, this is the lines, right? So for here, this line is here. Okay, so this line is increasing line, and because it's a line, so what happens here? The slope is fixed. It doesn't matter which point, right? So we know, hey, here, all right? And then the reason why in here I have circles here is because I know I cannot take the derivative at the sharp points, right? So that is why in here you got the circles there. Okay, so now let's take a look at the next ones here, right? So like in here, then you see this things here, right? So these things here is still the line, and it's decreasing, it's kind of declined, you're going downhill line. So the slope has to be negative, but also it's a line, so slope is constant. So this one is corresponding to here because it's a constant slope. Then the same way is here for this part here, right? So this part is a positive slope and going up, and also is a constant, so it's here. Okay, so I know the part B going to match what? Number 4 here. Okay, now let's take a look again. So the number A here, right? So number 1 is here. So we say here, okay, so here this is a decreasing, 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 correct? And then after they hit the decreasing here, after they hit this point, okay, where is my things disappear? Okay, so it's a decreasing, decreasing here. Then when they hit this point, then what happens here? This is going to become increasing, increasing here. You get that? Okay. Okay, so now, because this is, so I know because here, right? So it has to be something touched 0. And because this is decreasing, decreasing, so what happened to my derivative has to be negative. So I know is here, right? So this is corresponding to this one. And then when they hit this, this point here, they have to hit zeros, right? Because we said f prime x equal to 0 is when it changes, right? Okay, now let's take a look at this purple one. Then they start to increasing, 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 increasing till this point. Because it's increasing, so I know my derivative has to be positive. So this has to be on top of here. So it's here, right? So, and when they hit here, this is the point when they hit, right? And now the remaining part here, this is going to decreasing, decreasing again. And then in here, that means this one's here will corresponding to this one here, right? And then in here, you say, why this purple one have a kind of the curves here? The reason why is when they're increasing, right? So that if you enlarge this one, the first one, they increase in pretty steep. Then as soon as they hit the 0, they're still increasing, but the slope kind of going to flatter, right? So that's why even it's still increasing, but the slope going to get smaller and smaller. So that's why it's kind of decreasing here, but it's still above the zeros, right? So this one, right? So this is matched number 2 here, okay? Now let's take a look the other ones here. Okay, the other one, the easy ones is going to be where? Which one? Going to be this one here. Here, this is 1 point, 2 point, 3 points, right? So I know I'm going to have 3 point touch 0 because this is the turn from increasing to decreasing, right? So I have 1, 2, 3. 3 points is touch 0. So then let's take a look at what is the correspondence, right? Okay, so the first R, this one is what is increasing. So increasing is a positive, so it's here. All right, and then the next one is here. Okay, so this area is decreasing. right? So this one is decreasing. So it's corresponding to this area. Then you say, why is like a curve here? Because it just same like here. If you enlarge this picture, you will see the decreasing, this first start a very steep slope, then kind of gradually kind of turn, right? So the slope getting flatter and flatter. Okay, so the number 3 is here, this part here, right? So this part is increasing again. So that means corresponding to this part is increasing, right? So the same way, if you enlarge this, you will see the increasing, the slope start out very steep, and then kind of flatten it down, but still is increasing. Just the way of the rate of increasing is getting smaller. Then here, the last one here is here, right? So it's corresponding to here. Okay, all right. So this is so I know the part D. So this is a very good problems, right? So part D corresponding to part 3. So of course, then the part C corresponding to part 1, right? So let's take a look at why. So the first things here, you recognize here, right? So this is point, right? So from the decreasing to the increasing. So that's why it's touched 0 here, all right? And then in here, all right, so in this ones here, this is decreasing, right? But the rate of decreasing, so it's decreasing, so has to be below. So that's what it means it's less than 0. It's just the rate of the decreasing changes here, right? Okay, now the same way in here, this part is started increasing. When the increasing, then the derivative has to be the positive side, right? So that's why this is corresponding to the 1 here. Okay, so if you get a good understanding of this graph, and then I think you have a pretty good understanding about the relation between the derivative and its function. Okay, before we do 23, 26, let's take a look this one's here, number 50, right? So this figure, so you have A, B, C, D, right? So which one is which? Okay, so you take a look here. Okay, let's take a look. Let's take a look at the D here. Okay, D, this is the gray one, right? The D here, right? Okay, so take a look at the D's here. So D has a return point, right? So this point and what? And this point, right? So they change from increasing to decreasing, and then from decreasing to increasing here. So I know, so for D, because of changes, right? So that means what? That means the derivative of the D, has to have what? Has to touch 0 at these 2 points, right? So which one most likely going to be touch 0? See here, you go like here. Oh, which one is here? Is the C's, right? So C is the only graph has here, right? So the C is the only graph, has the signs here that touch the zeros, right? Okay. Okay, so that's why, so the D prime, so I know that means if you take the relation here, this is D prime equal to C here. So correct? Okay. Okay, now let's take a look. Okay, so now we got the relation of the D primes here. Now you take a look here, all right? So you take a look at C right now. Okay, the C here. Okay, so C here seems like it start to change to here. So this is like going down, 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 right? So the C is going down, 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 down. So it's a beginning is a very sharp down, but still then the kind of the tangent line get flattened out, and then start very flat and then going up, 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 right? So take a look. That means the derivative of the C has to be what? it has to touch the zeros, right? So, okay, so here's a touch the zero. And then it should be start very, very negative and then gradually hit it, then doom, turn. So which one has the negative slope? Which one is negative here, right? So this, this blue one, you see that? All right, so that's why we know the blue one, you know, is what? Probably is what? So I know the C prime will be equal to the blue ones, right? Because C is this golden one, so the blue one, so is equal to B. So get that? Okay, so now let's take a look at the B's here, right? So the B, okay, so the B is here, Okay, so if you take a look at the B, it's the blue one. So these ones here, first they have a very what? So the tangent is positive, right? Then the tangent line start to get a negative. So start out flat, you know, I'm sorry, still positive slope is going up slope, right? So this ones here is like a very strong slope, positive slope, and then kind of flattened out, and then it's getting stronger and stronger, right? So which one is that? It's this one, right? So both the slope is positive. They just kind of the first start very steep and then gradually flatten out, right? Okay, so now I can say here, then I know the B prime is equal to what? Equal to A, correct? Right, so if you compare the relation, if you know what we talked about before, so now I can see that. So what is the first hierarchy one? So I know the D is equal to my f of x, and the D prime equal to C. So C is equal to my f prime x, correct? Okay, and then the D, C, B, B is the derivative of C, so B is f double x. Then what is the A is here? A is triple X here, right? So as you can compare the relation. That's why we say it's very important you understand the relation between the function and its derivatives, right? So then you'll be able to know this. Okay, so now let's take a look at this ones here. Okay, so these ones here, I have A, B, C also. Identify which one is which here. Okay, so now in here, let's take a look here, right? So these curves here, you know, I'm starting, so like A, so this is going up, 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 right? Up, up, then kind of flattening right in here, then the slope going like going the negative slope. So the A, so if this is my flat slope, that means my derivative has to be what? Has to be 0, correct? Because so which part is giving me the possible derivative equal to zeros here? This one, right? So because the B, okay, so this match out quite well, right? So B is this golden one. So let's take a look here. The slope here, so they are all increasing, right? They are all increasing, but the rate of the increasing start slow, small, then become very steep, right? Okay, so then like become steep and then kind of flattened out again. So it's start small, then they come steep and then flattened out. Then when they come to, when the A come to this range is here, right? So hey, here, that's what the B go to this range, go to the negative, because the slope going to become negative, right? So when the slope become negative, so the B go to the negative. So I'm sure the B is equal to the derivative of the A, right? Okay, so now, so let's say here, so if I say A is f of x, then B is f prime x here, okay? Then let's take a look at the f double prime will match or not. Okay, so f double prime right now, we are looking for the B's here, right? Okay, so the B, if you take a look at the B here, right? So B here, this is the tangent line. Okay, so the B going to hit the flat ones here, then go down, 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 down. Okay, when they hit the flat one, that means its derivative going to hit the zero. So that means which one going to hit the zero? That's pretty good, right? So C is hit the zero. Then let's see the increasing, decreasing match or not. So B for this area is all increasing, right? If it's all increasing, so should corresponding to here, right? So the C is here. And then after it turns, right? After it turns, the B start to go into decreasing, right? So it's decreasing, that means the C going to be negative. That's why the corresponding here is negative. Okay, so we know this match also. So we know the B derivative going to be C here. So that means the C is equal to what? The double derivatives here. Okay, so we have a lot of the problem try to show you the relation. So we need to know very well, because if not, in our next unit, when we talk about the graph, then like when we start to introduce like the second derivative, third derivative, and then the relation of the graph. So we need to know the relation of the graph is always like if the second derivative, that means you'd always look for the rate of change for the first derivatives, right? Okay, so now we finished this, so we should get a pretty good idea. Okay, so now in here, we talk about the graph is here. So we say which one is not differentiable and why. Okay, so take a look at the first ones here. So we have a few. Remember we said we have a three, the undifferentiable is the sharp points, right? So here, this is a sharp point. So x equal to -4 is not differentiable. Why? Because this is a sharp point, right? And then at x equal to 0 is not differentiable. Why? It's discontinuous, right? So we have to be continuous. So this is discontinuous. Okay, so now let's take a look at the second one here. This one is not continuous, right? So x equal to 0 is not differentiable, it's discontinuous. Any other ones here? Got a sharp point here. So x equal to 3, this is not differentiable. This is what? This is a sharp point, right? So all the others looks good. Okay, so now let's take a look at this one. Okay, this one, obviously, this is a sharp point, right? So x equal to 4, this is a sharp point. Okay, so this is a sharp point, right? Then also in here, right? So in here, if you take a look here, if you find the tangent lines at here, what happens here? So when x equal to -1, what happens here? We have a vertical tangent line. The vertical tangent line, we know the vertical tangent line, vertical lines is like this, right? The slope is not defined, right? So that's why it's not differentiable. Okay, so now let's take a look at this ones here. The last one, this one is easy. So this is what? So x equal to -1. So what happened to this ones here? This is a discontinuous point. Any other ones? Oh yes, I have a sharp point here. So x equal to 2. This is what we call this the sharp point. So it's not differentiable, right? So the differentiability is like you have to be continuous and the function has to be smooth. You cannot have a sharp points here. Okay, so now let's take a look in here. They say find the derivative of the function using the definition of the derivatives. We did this a lot of these problems on our previous one to try to use the limited h approach to zeros here. So now, and let me try to just, this ones here is pretty easy. You just, like in the previous practice, we did a lot of those practice. You just need to be very careful about the algebras, right? Okay, so now let's try to do number 26 here. So we say the limit h approach to zeros, right? So this is h, f g of the t plus h, right? So g of the t plus h minus gh here, all right? No, minus gt is here, right? Okay, so here, okay, so we just need to be, also these ones here, we just need to be extremely careful about our algebra. So this is limit h approach to 0, g t plus h. So what is here? This is t plus h minus 1 over square root of the t's, right? Okay, so now you say this is limit h approach to 0. So this is h, then you say common denominator. So the common denominator is t square root of the t plus h, right? You just times the denominator. Then this is the square root of the t minus the square root of the t plus h, right? Okay, so like I say, if you are patient and be careful, then this is h, and this is square root of the t, and this is square root of the t plus h, right? So then here this is t minus the square root of the t plus h. So if you plug in h equal to 0, unfortunately, you will get a 0 over zeros, right? So we know the 0 over 0 is indeterminate. So like we talked before, if you see the square roots, what is the typical trick we're going to do here? What do? We type the conjugate, right? So we said the conjugate, this is t plus h, and this is square root of the t plus h. So basically you times once, right? So make no difference. The reason why we want to times the conjugate is because what I want to use this formula, right? A minus b times a plus b is equal to a squared minus b squared here, right? So we say this is an extremely useful formula. Okay, so this is a limit h approach to 0. So your denominator will be pretty big. So this is the h, and this is a t, this is a t plus h. Then this will be the square root of the t plus the square root of the t plus h. Then the top will be a squared minus b squared. So it will be t minus t plus h. Okay, so now in here, let's simplify this a little bit. So the denominator, numerator t minus t plus h, so it's negative h, right? So it's easy. Then the bottom, this is h, and this is t, and this is t plus h, and this is square root of the t plus square root of the t plus h. Remember, right? It's just be careful when you do algebra and be organized. So now the h and h can cancel. That's good. And then when h approach to 0, this one approach to 0, this one approach to zeros, right? And at the top is what after you cancel is ones, right? H and H. Okay, so now let's see here. Now this will be the negative 1. So this is the square root of the t times the square root of the t. Then this is the square root of t plus the square root of the t's, right? Okay, so simplify this. This is, so what is this one here? This one is t's, right? And what is this one here? This is 2 square roots of the t. So now you combine what is the final answer? So this is 2t to the what? 3/2. And this is my g prime, right? So this is my g prime. So okay, so this is my g prime t. Okay, so this is g prime t here. Okay, they want to find the function, then they want to also find the domains, right? So let's take a look. GT is equal to the 1 over square roots of the t, right? So we know the domains for here, the denominator cannot be 0 and the inside the square roots have to be positive, right? So the domains here will just be t is where from the 0 to the infinities, right? Okay, so this is the derivatives, right? So this is a derivative. Now, what is the domains here? The same things here, right? So if you simplify this one, so this is -2, the square roots of the t cube. So it's the same thing. T cube has to be greater than 0, right? Because inside the square roots and it cannot be equal to 0. So what is the domain here? The domains here is t also has to be from 0 to infinities, right? That means that in here the t cube has to be greater than 0. That's why t has to be greater than 0, right? So it's from 0 to infinity. So as you can see for these functions, the derivative and the function have the same domains here. And sometimes it is not necessary. They always have the same domains here. Specifically later in our next unit, and sometimes your derivative, then the domain going to change from your original function. But for this one, we are lucky they are the same here. All right, let's for this topic that is derivative as a function. So for here, remember the most important part is recognize the relation between the original function and its derivative, and how their graphs performs here. All right. Okay, it's nice to talk to you, and then that's it for this unit, and looking forward to start a homework helper for the next unit here. All right. Okay, and bye. Have a good day. Okay.